So, let me ask you something. You ever had a background task in your Java app just stop? I mean, no errors, no crash, it just vanishes into thin air. If that sounds familiar, you're definitely not alone. Today, we are cracking that case wide open by exploring the secret world of Java's Daemon threads.
All right, let's set the stage for our little investigation here. We're looking at a scenario that trips up a lot of developers. Just think about it for a second. You've written some code for, logging or maybe monitoring something, maybe some kind of cleanup task that's supposed to run in the background. You fire up your application, everything looks great, and then, poof, your background job is just gone.
And that's what makes it so weird, right? The rest of your application, it finished its work perfectly. You're checking the logs, and there's nothing. No exception, no emergency exit. It's like a ghost in the machine. So what is going on here?
Well, it's time to introduce our prime suspect. It's a special kind of thread that loves to work in the shadows. We like to call it the silent servant.
So this is the official definition, the one you'd want to have in your back pocket for an interview. A daemon thread is basically a background helper. Its whole job is to serve the main user threads. But here's the absolute key piece of evidence. It does not stop the Java virtual machine from shutting down.
Let's break that down a bit. Daemon threads are designed for non-essential stuff, housekeeping tasks. Think of them as the roadies for a rock band. They're working while the main show is happening. But, and this is so important, there is zero guarantee they'll finish what they're doing. The second the main show is over, boom, the lights go out and they're done.
Now, to really understand our suspect, we've got to put it in a lineup next to its counterpart, the user thread. The difference between these two is the secret to this whole mystery.
This table just lays it all out, crystal clear. User threads, like your main method, they're the stars of the show. They are the core logic. And the JVM, it'll wait patiently for every last one of them to finish before it goes home. But daemon threads, nah. They're just for background services, and the JVM completely ignores them when it's deciding whether to shut down. And that means their completion is never, ever guaranteed. If you only remember one thing from this whole explainer, make it this sentence. Seriously, this is the perfect one-liner. User threads are the life support system for the JVM. Once all of them are gone, the machine powers down, and it doesn't matter what any daemon thread was in the middle of doing.
Okay, we've arrived at the heart of the matter. This is the one single rule that explains everything about why our task just vanished.
This is the fundamental law of the JVM. It's a very predictable system. It waits for every single user thread, all your main logic, all your request handlers, to wrap up their work. But there's a catch.
And there it is. That's the motive. The JVM just does not care if a daemon thread is halfway through writing a file or updating a metric. The moment that last user thread signs off, the JVM just pulls the plug. The lights go out, and any daemon threads still running are terminated right then and there.
So what does this actually mean for you? Well, the implications are pretty severe. It means any line of code in a daemon thread can be stopped dead in its tracks. And get this, even a finally block, the thing we always rely on for cleanup, is not guaranteed to run. This is why you must never, ever perform critical work, like writing to a database or a file inside a daemon thread. It's a recipe for disaster.
Okay, mystery solved. Now let's look at where these silent servants actually show up in the real world, and a few common traps that developers often fall into. The funny thing is, you've been working with daemon threads this whole time, maybe without even knowing it. The most famous one is the garbage collector, always running in the background, cleaning up memory. It's the perfect example of a non-essential task. I mean, the JVM isn't going to wait around for a full GC cycle before it shuts down, right? This is the #1 example to bring up in an interview, by the way. So how do you make one yourself? It's really simple, but there's a critical catch. You create your thread object, same as always. Then you have to call setDaemon_true before you call start. That order is non-negotiable. If you try to change its status after it's already up and running, Java will just throw an illegal thread state exception at you. So yeah, order is everything here.
All right, let's bust a few myths real quick. First, daemon threads are not guaranteed to be low priority. The spec doesn't say that. Second, and we've hammered this home, the JVM absolutely does not wait for them. And third, and this is the big one, never, ever put important business logic in a daemon thread. It's just asking for trouble and potential data loss.
So we've covered the what, the why, and the how. Let's wrap this all up with one final golden rule that perfectly summarizes everything we've just learned. This is it. This is your powerful closing statement, the perfect summary. Daemon threads are your background helpers. They do the support work. They won't keep the app alive, and because of that, you can't rely on them to finish. Use them for things that are okay to abandon midway, but never for anything that absolutely has to complete.
And that brings us to the final question, and this one's for you. I want you to go back and look at your own projects. That little background task you wrote a while back. Did you happen to set it as a daemon? Could it be the next victim in one of these mysterious disappearances? Now you have the tools to be the detective.